Hello everyone, how are you all doing? This is part 2 of cloud computing fundamentals. In part 1, we had discussed about what cloud computing is. We actually started from what computing is, considering people who are completely new to cloud computing or even IT. And then we discussed about what is cloud computing and what are the different types of clouds available, like a public cloud, private cloud, and hybrid cloud. Let me also share the screen and go through the slides to quickly refresh your memories. And if you have any doubts, you can stop me and ask me. Otherwise, we will start with part 2. So, cloud computing fundamentals part 1 we already discussed. It was basically the road to cloud and cloud deployment models. And we had discussed about computers and data center, what is a computer, 5 most important parts of a computer, such as CPU, GPU, RAM, storage, motherboard, etc. And also we briefly went through the history of computing from bare metal machines, server virtualization, containers. We also discussed in detail about what is a data center. And we started with cloud computing, with the definition for cloud computing, and also 3 deployment models: public cloud, private cloud, and hybrid cloud. And we went through some examples to make sure you understand what all these public cloud, private cloud, and hybrid cloud is. And we went through some additional topics such as private cloud versus traditional data centers, SDDC. And today we are going to get started with the cloud abstractions and the cloud features. So before we get started, I wanted to make sure if you have any doubts or questions based on the slides we went through. So the last session and today's session primarily is focused on introduction to cloud computing. And as I have already mentioned, this is not just some prerequisite sessions. The knowledge of these 2 sessions are actually needed for the fundamentals certifications of Azure, AWS, GCP, and most of the cloud providers, because most of these cloud providers have the fundamentals certification structured in a way that it is not fully that particular cloud. For example, if you take Azure Cloud, the module 1 of AZ 900 or Azure Fundamentals exam does not speak much about Azure Cloud. It speaks mostly about cloud computing in general. So, irrespective of whether you are planning to learn Azure Cloud or AWS Cloud or GCP, whatever we are learning in these 2 sessions are relevant. Okay, so that said, we can get started. Traditional cloud abstractions or cloud service models. Why I mentioned the traditional cloud abstractions is because when cloud came and when I started learning cloud, almost for many years, all the comparison charts used to refer to these 3: infrastructure as a service, platform as a service, and software as a service. But as cloud progressed, we have currently a lot more additional cloud abstractions, as we will see in later slides. So, the traditional cloud abstractions, infrastructure as a service. What do you mean by infrastructure as a service? So, when you say infrastructure as a service, it abstracts away all the physical infrastructure layer and expose computing, storage, and networking as service. So now you understand why we learned about parts of a computer, right? So these things such as the CPU, which comes under computing, or storage, or networking, all these components of that computer that we learned are now virtualized. Meaning what? They are physically present in some place, and that same physical thing or a single physical thing is now given to us. It will look as if we are having a single computer of our own. But behind the scenes, most of these components are actually shared by many users. Okay, so that is server virtualization, right? A single physical host machine is now used by different people based on some software that is making sure everybody gets their share. Okay, you cannot use more than what you can use, and that software will make sure, okay, all of these different components are given to all of these different people in a way that these people will not understand what is actually being shared, right? So can you tell me the name of that software that actually does this server virtualization? We learned it already. So do you remember the name of that software that help us do server virtualization and help us use these resources without actually getting the feeling of actually using the same resources? Yes, it is a hypervisor. And we learned two types of hypervisors, right? So what is this hypervisor that we are talking about that runs on top of a physical host machine and make sure there are different operating systems running. In each of these operating systems, get a feeling that, okay, I am running on my own computer. So what is that version of or type of hypervisor called? We have two, right? We have type 1 and type 2 hypervisor. What is the hypervisor type that does this server virtualization primarily on cloud? Is it type 1 or type 2? This is fundamentals session, and then I am taking it a bit slower also, but I need a response. Otherwise, you will not learn much. Okay, I will repeat it again. So we have your host machine, okay? And then a hypervisor is managing different operating systems on that host machine. So that host machine can be called as a bare metal machine also. So whatever cloud abstraction that we are seeing here, infrastructure as a service, basically is it a type 1 or type 2? It is type 1, right?
Type 1.
Yeah, it is type 1. So you have physical machines and it is made available to multiple users through type 1 hypervisor. And what is type 2 hypervisor? With type 2 hypervisor, you already have an operating system and you can run another operating system on top of it, mostly for testing or development or simulations and all. But from a cloud provider's perspective, your Azure or AWS or GCP is not going to run an operating system, and on top of it, they are not going to run a virtual machine and give it to you. It will not have the same performance as type 1 hypervisor. Clear? Example, I think we had discussed more examples in the cloud computing or the container video. Consider type 1 hypervisor. There are many examples from VMware and other providers. And most commonly, it is used by cloud providers or enterprise companies to run multiple virtual machines on a single physical host machine. Yeah, ESXi, Hyper-V, etc. And when it comes to type 2 hypervisors, they are usually most by individuals for learning, development, etc. For example, if you have a Mac operating system and you need to run Windows on top of it, or you need to run Linux on top of it, or you have a Windows and you need to run Linux on top of it for any purposes. For that, we can use type 2 hypervisors that include VMware, Fusion. There are many examples we discussed earlier, right? These are just software that you install on top of a operating system, and then we do our things on top of it. So if I recall correctly, we are discussing some of these hypervisors in action as part of our Kubernetes 101 session. So if you watch or attend Containers 101 and Kubernetes 101 sessions, you will understand more about type 2 hypervisors. Okay, so the recordings are available if you want to watch, or if people are interested, we can have repeat sessions also. And then with infrastructure as a service, the unit of scale is operating system. So whatever we are going to get access to is the operating system. We don't have to worry about how virtualization is done or how this hypervisor is doing its magic and all. It is all taken care by your cloud provider and all those setups. So we have to start worrying from the operating system level. So with infrastructure as a service, we have to do many things. So if you are given a computer and if you are asked to set up a website, so how many of you have heard about this LAMP stack? LAMP stack is a general term used for the combination of Linux, Apache, MySQL, and PHP. So there are many websites out there, such as WordPress, that are using PHP. And as we are planning to do our lab for Azure and AWS non-development track by deploying WordPress and then setting up things on cloud, it would be worth to know that, okay, this WordPress is a PHP based website and it is generally deployed on a setup that is generally called as LAMP stack, Linux, Apache, MySQL, and PHP. Okay, so in case if we need to do this setup for a LAMP stack for deploying a WordPress on a virtual machine, what we have to do? We have to either we can also set up these things in Windows, but most of the production systems, as you know, will be mostly running on Linux. So we need to have a operating system that is running on Linux, and we need to install Apache. We need to install MySQL. We need to install PHP, and then we need to deploy our application into it. And whenever there are many components here, right? So whenever any of these components change, for example, if what are the components that can have changes? Operating system. So most of the operating system providers will be providing regular patches. So whenever some vulnerability is found, they will be providing some kind of patches. Similarly, all of the other software, right? MySQL or Apache, PHP. So any of the any of these components, if they have some patches or vulnerabilities, we have to look out for them and we need to update our environment. So we need to update by patching our operating system, patching MySQL, patching Apache, patching PHP. So these are just few examples, right? And there are a lot of other components and other software that we need to install and manage and patch and do all of these things. So that is where the next evolution came, which is a platform as a service or PaaS. So here, our cloud provider will take care of the virtual machine, operating system, the runtime, and the developers are only responsible for the application. So when we learn about Azure App Services or similar things on AWS side, we will see that, okay, we have options to select what operating system we are going to use and what runtime. For example, we can say that, okay, I want to work with Java this version or PHP this version or .NET this version. And after selecting Java, you can also say that, okay, I want to go with this server. For example, a Tomcat server of this version. All of these things you have to just select and your cloud provider will provision it for you on demand then and there. And you only have to make sure you create an application and you deploy it. And even for your database also, you can just provision a database on cloud, which is completely managed by your cloud provider. For example, Azure SQL is one popular option within Azure Cloud. You don't have to install the Azure SQL database. You just have to say what configuration you need, and your cloud provider will automatically provision it for you. And all these components, whenever they have patches or other security bugs or anything, your cloud provider will take care. So you are only responsible for your application, and that is why the unit of scale here is application. With infrastructure as a service, it was it was operating system, and with platform as a service, it is application. So now tell me one thing based on your understanding or based on what you have heard, or just make a guess. Which of these will be costlier? from a cloud billing perspective? Is it going to be infrastructure as a service or platform as a service? Which of these is going to be a costlier, IaaS or a PaaS from a cloud billing perspective? Okay, so the answer is platform as a service will be little more costlier than infrastructure as a service from a cloud billing perspective. So now if I ask you another question, which of this will be costlier from a operations perspective? From your operations team's perspective, from your company's billing perspective, which of these will be costlier? It will be infrastructure as a service. Why? Because if you look around, why are we having a lot of layoffs these days? Because most of the companies are cutting down human part, and then most of the things are getting automated, or many of the things are now done by AI. So the human intervention is becoming less and less. As of now, as Amit has mentioned, everybody is focusing on how to reduce cost. And if you consider IAS and PaaS also, PaaS has more cost if you look at the billing for cloud. But when you look at the actual cost of running these two, IaaS is much, much costlier. Why? Because somebody has to do all these things, right? Somebody has to do all this patching, and those somebody are engineers. And the salary of engineers, when it is compared to the extra cost of a platform as a service, is much, much higher. So what will companies do? Okay, let us reduce few engineers and let us focus on PaaS. Similarly, the next evolution comes, then people will move to that. So there will be trade-offs, right? So some of the evolutions will have some trade-offs. So that is where architects come and then decide. They consider cost, they consider the future of the company, they consider feasibility, they consider portability, and all these things combined, they will take a decision to go with IaaS or PaaS or the newer ones such as serverless and others. I have got these questions from managers, especially who are new to cloud, on seeing just the pricing comparison. Why will people go to PaaS for saving cost when I can see clearly that, okay, PaaS is costlier than IaaS? So it is not just the cost of cloud billing, but it is also the cost of people who are managing it. So next is a software as a service. So if you consider infrastructure as a service and a platform as a service, both of them are from a developer perspective. So when I say developer here, it is not the development team who does the coding. So when you consider an application such as Gmail, so is Gmail that application Gmail, is it a SaaS or PaaS or IaaS? So from a user perspective, from a end user perspective, it is SaaS. But from a Google perspective, so here who is the developer? So developer is Google. When I say developer, as I mentioned earlier, it is not just the person who sits and code. Everybody from the company that produces Gmail, they are all called as developer from a App Store or Play Store or similar perspective. Okay, so from Google's perspective, it could be PaaS or IaaS or serverless or whatever way they have implemented. But from a end user perspective, it is SaaS. Even it's the same with Office 365 also. Okay, from a end user perspective, it is SaaS. But behind the scenes, from the developer perspective, developer company perspective, it could be any of the other models such as IaaS, PaaS, or serverless, etc., etc. Okay, even developers use some of the SaaS services. Okay, and with these different models, we have a shared responsibility model for maintaining it securely. So with an on-premises data center, what do you mean by on-premises? Everything is managed by you on your own data center or on a data center that is leased by you. We discussed all of these things in part one. With a shared responsibility model on a cloud, responsibilities get shared between the cloud provider and the customer. So physical security, power, cooling, network, and connectivity are all the responsibility of the cloud provider. The customer is responsible for data and the information stored on the cloud and for providing access to only those who actually need it. But the exact responsibilities depends on those abstractions, right? IaaS, PaaS, SaaS, etc. To understand this, so we can quickly go through this diagram. On premises, everything is your responsibility, right? Customer managed, the green ones, application, data, runtime, middleware, OS, virtualization, servers, storage, networking, everything is your responsibility to manage. With infrastructure as a service, virtualization, servers, storage, and networking, all of these are managed by your cloud provider. And Rust operating system, middleware, runtime, data applications, it is your responsibility. And with the platform as a service, everything until runtime, your cloud provider will manage, and Rust, your data and applications, you have to manage. And with software as a service, everything is managed by your provider. It could be a cloud provider or some SaaS provider, and you are only responsible for access. So access is not mentioned here, but you are responsible for access and configuration and all those things. Because if you write down your username and password and then put it on your desk and then leave for coffee, and somebody takes that and then does something bad, you cannot blame your cloud provider for not stopping it, because it is your responsibility to manage your access correctly. Okay. And these are some of the newer cloud service models or abstractions: identity as a service, or IDaaS. Yeah, tell me, what is the service for IDaaS in Azure? So you have heard about Azure. This is one of the most popular services. Okay, I wanted to hear that Azure AD, but do we have an Azure AD now? What is the newer name for Azure AD? Yeah, Microsoft Entra ID. We had a session where we learned about the new term, and we even had a common session where I updated the presentation and all. So we have Entra ID, previously called as Azure AD. Similarly, most of the other cloud providers have, and we even have common ones such as Okta and all. And next we have a container as a service. So here also, we don't have to manage the containers. We can just create containers and we can use it. Another very popular one after infrastructure service and platform as a service from a developer perspective is serverless. When you consider serverless, the primary as a service that we talk about is a function as a service. But now many of the cloud providers and other SaaS providers also consider no code or low code solutions also as a serverless. So tell me one thing, in serverless, do we have servers? I need everybody to try and answer this. In serverless, do we have servers? Okay, that is good. So everybody agree that in serverless, we need servers. Now tell me why it is then called as serverless. So similar to infrastructure as a service, where we are responsible for managing the operating system, and with platform as a service, where we are responsible for managing the application. With serverless, everything is taken care by your cloud provider, and you have to manage your code. Or with the no code or low code, you may not have to even manage your code. You just have to manage your logic. So everything else, all the management of infrastructure, or all the management of server, when you consider a server here, it is not just a physical server. It is also the software runtime server. For example, the Tomcat server for Java, right? So none of those things you will have to manage. All of those things will be managed by your cloud provider. So you just have to write your code and give to your cloud provider, and the cloud provider will execute it. And with no code or low code, you don't even have to write code. In most of the cases, you just have to do some drag and drop and all those things, and everything will be taken care. All the logic will be implemented behind the scenes, and you don't have to worry how it is implemented. So there are many no code or low code solutions out there. Even Azure has something. So can you name the service from within Azure that comes under this category of no code or low code? Okay, logic apps. App service is not serverless or no code or low code. It is actually PaaS. It is platform as a service, as we learned and as we will be learning deeper in our upcoming ACID 104 Azure Administrator course. So function as a service means you just take care of the function, and you don't even have to create an application or build an application and deploy an application. Only have to write your function or code. So if you consider an application written using Java and deployed to app services or deployed to virtual machines, you will need an application, right? So app services means you are deploying an application. It is a pass where application is the unit of scale. You need an application. And when you are deploying an application in Java, most probably you will not be creating all those application code from scratch. You will be using some framework. Okay, most of the languages have their own popular frameworks that you use. And in Java, if anybody is familiar with Java, can you suggest what is the most popular framework that is in use today? So it is Spring Boot or Spring, in my opinion. And you have to develop a Spring Boot or Spring app and then deploy it into app service. And within that Spring Boot or Spring app, you will need to write your functions and other code also. So you need to learn Java to write these functions. You also need to learn Spring Boot and Spring and all of its functionalities to build an application. And you need to update your Spring Boot or Spring app whenever the app changes. You need to do migrations and a lot of things. So it is not just the physical software or runtime, even the application and application frameworks and other things you will have to update or patch and migrate and do all those things with platform as a service. But with the function as a service, that part is also taken care. So everything is taken care by your cloud provider, and you just have to write your functions. Very sweet, right? And as we discussed in our earlier session and also in container session, so this is not just so this is just one of the features of serverless. That is, you don't have to manage your application, you just write your code. What is the second feature of serverless? Anybody remember? The second feature is you need to pay only for the time your service is being used, right? With platform as a service or with infrastructure service, if you are building an application, if you are running it, imagine that you are having a website, right? Imagine that you are having a website and you are running it all the time. Unlike a physical shop, you cannot stop a website at night and go, right? Basically, you will have to run it all the time. And that means even if you say pay as you go, effectively you have to pay for all the time, right? You have to pay for all the time. The only advantage is, or the most important advantage is, compared to the physical on-premise infrastructure, if you decide that, okay, from tomorrow I don't need this infrastructure, you can just stop. But with the physical, you'll have to sell it or you'll have to convert into cash, and you will definitely incur losses. So that is an advantage with respect to on-premises. But with respect to serverless, you still have to pay. So if your website is running for 1 week, even if you don't have any customers, you still have to pay for that 1 week. But with the serverless, the idea is that only when your services are invoked, that means if you have a customer that is using the service, then only you will get charged. And for that, containers play a very important role. So we are not going deeper into that, but just keep that in mind. So the more you go up in an abstraction hierarchy, so the more easy it is to develop an application. And sometimes you lose a little bit of flexibility also. For example, infrastructure service has most flexibility. You are free to decide a lot of things, but with the path, flexibility reduces, and with the serverless, it further reduces. So you have to take that call whether I need easy development, I need fast development, or whether I am looking to move to another cloud provider in future. I need flexibility. So think about all these things. Again, these are the things that your architects will think about, and you will be mostly implementing these things as a developer or as an administrator or a standard DevOps engineer. But ultimately, all of you have to grow towards an architect role. And that is why I'm explaining those things also. Because many of the people who are doing Azure Administrator 104 will be going for 305 or 400 based on your interests. So, and data storage in cloud, these are some of the popular options. You have a file storage, you have block storage, you have object storage. And file storage examples are EFS or Elastic File System in AWS, Azure File Storage in Azure, and File Store in GCP. Block storage in AWS, you have Elastic Block Store. In Azure, you have Azure Disk Storage, and GCP, you have Persistent Disk. And object storage in AWS, you have S3 or Simple Storage Service, which is a very popular service. In Azure, you have Azure Blob Storage or Blob Containers. And in GCP, you have Cloud Storage. So, are you familiar with these terms? So, file storage, you can implement shared file system and you can put files on it. So, you'll be learning those things in detail as part of AWS and Azure tracks. And block storage, so whenever you are creating virtual machine, you need to attach some disk to it, right? And there are different kinds of disk, and that comes under block storage. And object storage is a flat hierarchy. So which means in file storage and block storage, you can create folders and subfolders and put data within those folders and subfolders. With object storage, you generally have a key and a value. Even though you see things such as folder 1 slash folder 2 slash folder 3, and then the data in an object storage, it is just giving you the impression that, okay, it is kind of hierarchical, but actually that folder 1 slash folder 2 slash folder 3, it is just a name. And then value is the actual data. So object storage is an easy way to store data and retrieve data. And it mostly uses APIs such as REST APIs. You just put data, you get data. That is it. It's very simple. But you cannot install an operating system on an object store. So, and when we go to AWS, Azure, or GCP tracks, we'll be learning all of these things in detail with hands-on exercises. And next, we have to be familiar with databases in cloud. So here are some of the popular options. So here we have many blocks, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So tell me, how many of these boxes you are familiar with or good with? You may not have to learn all of these for your Azure Cloud or AWS Cloud fundamentals or associate level certifications. But the more you go towards an architect role, you will need to learn all of these and what are the options available to you. Because as architects, whenever you get a database problem, first you will need to decide whether I need to go with a relational database or a non-relational database. And then you will need to decide if I go to non-relational databases, whether I need to go with a key value store or document store or columnar store or graph database. And there are many cloud agnostic ones available, and there are also many options available on the cloud. For example, if you consider relational databases, you have Azure SQL, you have Amazon RDS, you have Cloud SQL, etc. And when it comes to non-relational databases, so these non-relational databases are generally called as NoSQL databases. So this NoSQL, what do you mean by NoSQL? So initially, this NoSQL was called as NoSQL. Okay, initially this NoSQL meant NoSQL itself, but now NoSQL is generally referred to as not only SQL. So initially that O after N was small case. So now people generally keep the second O as a capital. The reason is because many of the non-relational databases also have SQL or SQL similar languages available. So it is not NoSQL. Now it is generally called as not only SQL. And there is not just one kind of relational database, there are multiple kinds of relational databases that are available. So some of these things, such as databases in cloud, are not part of Azure Cloud or AWS Cloud fundamentals. They are part of different fundamentals specific to data. For example, in Azure, you have a certification called as Azure Data Fundamentals. I think it is DP 900. So that covers this slide in a little more detail. But it's always good to learn and understand whatever you are working with, right? It always will help you a lot when it comes to deciding and when it comes to understanding why you are doing certain things at your work. To understand these things better, you will also need to understand a concept called as CAP theorem. So how many of you have heard about this thing called a CAP theorem? C stands for consistency, A stands for availability, and P stands for partition tolerance. In our systems design discussions, we had discussed the CAP theorem in detail. It is little more on the advanced or difficult side, but it is always good to understand those things if you ever want to be an architect. Okay, so I'll quickly explain. So relational databases, it works based on tables and their joining and other things. So it is mostly row-based table. And when it comes to non-relational, as I mentioned, there are different types. So you have key value stores, meaning you have a key and you have a value. It is very straightforward. And one very common use case for key value stores is building caches. So what do you mean by caching? So you have some data in your some database and you are calling it and you are getting that from a distant database, and you may be running a stored procedure or something on that database to retrieve that data. And that data can be stored near to your application in your application deployment. And so next time you don't have to go all that way. You have to just take it from your cache. So this caches and all will be much more costlier, but it will save you from that extra time that you need to go and come back. And at the same time, because of the cost and other factors, you cannot store everything on your cache. So you will have to remove certain data based on some algorithm at certain point of time. So that is called as a cache eviction. So for example, you can say that, okay, least recently used, I will remove. Okay, all these things we will discuss in much more detail as part of systems design discussions. They are optional discussions. So that is it about caching. And then we have a document store. How many of you have heard about JSON, JavaScript object notation? Okay, I'm introducing you to many terms and concepts in these initial sessions. If you don't know, just write it down, go find out a bit about it, or just ask me in the group if you really need a session, because all of these terms are important if you really want to master cloud or IT. So document store is basically storing documents or data in a JSON or similar structured format, which is not as structured as relational databases. For example, in relational databases, you have 4 columns. All the data will need to have that 4 columns. Okay, even if you don't put anything, it will be blank, but still all your rows will have that same column. But here, if you consider a document store based on JSON, for the first item, you can have different attributes. And for your second item, you can have different attributes. So in relational, attributes are generally represented by columns, right? So you cannot have different attributes for different rows or different items. But with a document store, you can have different attributes for different items. And MongoDB is a very popular example. And columnar store, Cassandra is an example. So columnar store is similar to relational databases, but it is different mostly from a performance perspective and use case perspective. So if you see a relational database with rows, all the rows behind the scenes, all the rows are stored together. And with a columnar database, all the columns are stored together. For example, if I have a row for Harkin, a row for Sam, a row for Amit, a ROM for sham. So all the details of Heartin will be stored together in database. So consider distributed databases and data spread across multiple servers and all, right? So all the data for Heartin will be in one server. All the data for Sam will be on another server. All the data for Amit will be on another server. Maybe it could be on the same server also. Just imagine that, okay, it is on a different servers. So if I need the details of one user, say Heartin, I can easily write a query and your distribution logic. So we'll learn about the actual distribution logic like sharding and all those things in our systems design discussions. Again, it is optional, but you are welcome to learn. So somehow it will be redirecting me to the right server, and from there I can read. So all the data for Heartin comes, right? But with the columnar store, your data for a column is stored together. For example, if my salary, so imagine that this is employee database, and then the salaries of all the employees will be stored together. Age of all the employees will be stored together. Similarly, other attributes. So what is the advantage with the columnar store? So which of these is good for general profile management or general management? It is relational, right? Because when I log in as a user, I need to see all of my information. And which of these is good for analytics? Analytics means what is the average salary in the company, or what is the average age of employees within the company. All these kinds of aggregations that are common as part of analytics. For all those things, columnar store is much more helpful, because otherwise with a relational database, if your data is spread across many servers, to do those aggregations, you will have to read data from all these different servers. But with a columnar store, all the data is on a single server, and hence you don't have to go to different servers. Clear? And graph database is another kind of a NoSQL database where you can represent a social media kind of connections. For example, you have one user, and then that user is connected to two different users, and those two different users are connected to three different users or one user. So those kinds of relationships we can represent using a graph database, and Neo4j is a popular example. Okay, we will learn many of these things in detail in our systems design discussions. So columnar store database is always on one server. So most of the NoSQL databases are distributed. Okay, even though you can install it on one server for learning purposes or development purposes and all, in general, most of the non-relational databases are distributed. That means deployed across multiple database servers. And there are many algorithms that does the data replication and other things. As I mentioned, sharding and replication, I think we discussed as part of systems design discussions. So how does this replication work? What will happen if one of those servers fail? All those things are dependent on the CAP theorem that we discussed earlier. So if you are going into data deeper, then understanding all those things will make more sense. Okay, if you are interested, we can discuss more on data also. Until now, are you clear? So shall we start with the benefits of cloud computing? Everybody, some response will be good, yes, or Y or C. So one quick question before we move to the next part to adjust my pace. So do you think my pace is okay, or is it too slow, or is it too fast? I don't think it is too fast. I'm trying to make it very slow, especially for the fundamentals classes. So is the pace okay, or do you need to be faster? Okay, thank you. So benefits of cloud computing. These are not just the benefits or features that are available only to cloud computing, but with cloud computing, we can achieve these features or benefits at a much lesser cost than on premises. So first one is high availability. What do you mean by high availability? High availability is ensuring an agreed level of operational performance, usually runtime, regardless of disruptions or events that may occur. High availability guarantees is generally represented using SLAs. You may have seen SLA for your software, right? 99% uptime. Most of the SaaS providers will provide SLAs, right? 99% uptime, 99.99% uptime, etc. And when architecting solutions from an architect perspective, we need to consider multiple things such as SLAs, RTO, RPO, etc. So what do you mean by RTO? RTO stands for recovery time objective and RPO stands for recovery point objective. What does it mean? So RTO means what is the maximum length of time it should take to restore normal operations following an outage or data loss. RPO means what is the amount of data you are willing to let go in case something goes bad. And your architecture is dependent on all of these things. Until you become an architect or entry level architects will be generally tempted to always go for the best high available systems. Okay, so if you go for the best computer and if you go for the maximum replication, you will get high availability for sure. You'll get the best high availability. But as an architect, your job is not to have the best high availability, but the best for your situation or the minimum that is needed for your situation. Because you also have to consider cost. Okay, considering the cost, considering RTO, considering RPO, what is the minimum I need? Whenever interns start working on things within the Trainso Cloudrix Forum C internship program, so initially we give some exercises even before this cloud computing fundamentals sessions and all, or maybe they go through it and then they do not focus on these things, thinking, okay, it is only for architects. And what happens? So whenever they create systems, they create with premium tiers, which will have extra cost. But always architects will look for doing things with the minimum cost. That means if I need this feature, I have to go with this pricing tier. And when you are writing certification exams such as 104 and 204, etc., you may have questions from app services and all asking, okay, what is the minimum tier I need for this particular feature? So actually, they will not ask you directly what is the minimum that is needed for this particular feature. Instead, they will ask you what is the most cost effective way to get this feature. So then you'll have to go with a pricing tier that is having a least cost but still support this feature. So it is always tempting to get the best high availability, but always go for what is really needed. That is same in life also, right? We are always tempted to buy whatever is best without even thinking whether that is really needed or not. Okay, so it is like want and need, right? And then comes two very important terms, scalability and elasticity. Scalability is the capability to adapt and perform well under an increased or expanding workload or scope. Scalability is generally achieved through elasticity. So what is elasticity? Elasticity is the allocation of required resources to meet current scalability needs, such as ability of a cloud provider to automatically add or remove systems based on demand. How many of you understood what scalability and elasticity is from just these definitions? So let us take a quick example, right? So imagine that a e-commerce platform such as Amazon or Flipkart or Walmart, and they will have sales, right? Big billion sale or Black Friday sale, or currently you have Diwali sales coming up in India. So some kind of sale will happen at some point of time, and the sales will not happen every day of the year. It will happen maybe for a week or a few days with some interval in between. And for these special situations, you will need more capacity servers to meet the demands.
For example, for a normal operation, you may need only 100 servers, and for the sale day, you will need 500 servers. So, how does 100 servers become 500 servers? So, can somebody tell me what is that called? 100 servers becoming 500 servers. Okay, it is scalability. But can you tell me what kind of scalability? So, there are two types of scalability. There is horizontal scaling and vertical scaling. So, imagine that currently 100 servers are serving the load, and based on demand, 500 servers are now scaling the load. What kind of scalability it is? It is horizontal scalability. So there are two kinds of scalability. So horizontal scalability means adding more servers in, and all of them working in parallel. And vertical scalability means when you have more scaling needs, you change the configuration of the machine itself. On demand, mostly your horizontal scalability is possible compared to vertical scalability. For example, it is not very easy to go and replace the RAM of a computer, right? When somebody is making a request. So changing the RAM of a computer or upgrading the CPU is vertical scaling. So adding more machines, okay, adding more machines is horizontal scalability. So just think horizontal means adding more servers, and vertical means upgrading the machine. Clear? So horizontal means adding more machines, and vertical means upgrading the machine. So scalability, you understand, right? So elasticity is that ability of your cloud provider to actually add these 500 machines based on the load. So how many of you have heard about auto scaling? So meaning you can configure, okay, you can configure if load is above 75, add one more server. Or for the last 1 hour, if load is less than 25%, remove one server. You can also configure minimum number of servers, maximum number of servers, etc. So this is auto scaling. So that ability that your cloud provider provides to actually does this scaling behind the scenes is called as elasticity. Okay, how many of you have seen a rubber band? So that rubber band is elastic. So if you take a rubber band, you can expand it, and then when you release it, it will come back to the original position. So you can expand and bring back to the original position and all. You can create another band which looks exactly like the other band, but it is not made to be elastic. So you cannot expand or you cannot bring it back. So when you look at it, both of them will look similar, but one of them is actually elastic and one of them is not elastic. So similarly, for a cloud provider, if it is supporting elasticity, then you can implement scalability on top of it. But if the cloud provider does not provide that elasticity, then you will not be able to implement scalability. So it is both related, and hence I put it on a single slide. And vertical versus horizontal scaling, it is something very important to understand. Vertical scaling generally refers to scale up or scale down. And scale up is replacing servers with more capacity ones or increasing its capacity. Scale down is decreasing the capacity of servers. Horizontal scaling generally refers to scale out or scale in. Scale out is adding more servers to share the load. Scale in is removing extra servers that are not needed. Many cloud providers provide automated horizontal scaling based on factors such as CPU usage and is generally referred to as auto scaling. So question, why do most cloud providers give auto scaling facility for only horizontal scaling and not vertical scaling? We learned, right? It is because it is very difficult to change the RAM or configuration of a machine automatically when requests are coming. That means on demand. Whereas adding more servers and directing newer requests to those new servers are easier to do. So fault tolerance and disaster recovery. So these are also kind of related. So fault tolerance is ensuring that servers or services remain available even if some fail. And disaster recovery is maintaining or quickly resuming mission critical functions after a failure. In both of these cases, failure can happen, but with fault tolerance, even if a failure happen, the system will still continue to support your users. How? Because more than one server might be supporting that request, and if one of them fail, others will continue to support. For example, a load balancer will be forwarding load to different servers, and it will have a logic to understand, okay, this server is up or down, and if some server is down, the next request it will direct to another servers. And to actually make use of this better, you will also need to develop your applications as stateless. Okay, so those are more on the architecture side, we will discuss later. And fault tolerance is generally implemented within a region. So when it comes to cloud, this generally means that, okay, within a cloud and within a region, you'll have multiple data centers. And most of these data centers are generally referred to as different zones. Okay, and then so these zones within a region, so they will be communicating with each other, sharing their data, synchronizing their data with each other. And then if one of them goes, others will be able to manage. But with disaster recovery, it is, you can consider, right? Disaster means maybe a whole region could go down. In that case, what is the best thing that you can do? Your service is down. You couldn't continue working like in fault tolerance, but the goal is how soon you can get back. You remember about RTO and RPO, right? So what was it? Recovery time objective and recovery point objective. What was recovery time objective? How soon you can come back. So that is how you configure your disaster recovery mechanism. So there also you can have different kinds of configuration. For example, you can say that, okay, your data is on one region and your replica is on another region. Either read both of them in parallel or read only from one. There are different configurations available, and the lesser the RTO, the cost will be more. So again, that trade-off you need to consider. So the primary difference is that in fault tolerance, service continues after a failure, and in disaster recovery, service may be interrupted but will recover faster. Clear? Question: what is the difference between high availability and fault tolerance? We saw the difference between fault tolerance and disaster recovery, right? So what is the difference between high availability and fault tolerance? If you don't know, you can always say D. That way I will proceed to the next slide. Okay, in high availability, performance and uptime in response to increasing demand is considered. With fault tolerance, only uptime in response to a failure is considered. How many of you have heard about DOS attacks, denial of service attacks, or DDoS, distributed denial of service attacks? So here in availability, your performance is also important. Okay, and with the fault tolerance, only uptime in response to a failure is considered. Okay, so what is preferred, low latency or high latency? So latency is the next feature or benefit. So tell me, what is preferred, low latency or high latency? Okay, good. It is low latency. So what is latency? So latency means you are making a request to a server. So the time taken for the request to go and response to come back, right? So low latency means less time is taken, and high latency means more time is taken. We are impatient people, right? So we like low latency, and our customers will also like low latency. So low latency is the ability of a system to access services faster through the internet. And how does a cloud help with global reach and latency requirements? Global reach means you can easily reach many regions globally for compliance as well as latency requirements. For example, if your business is in one country or a continent, and they say that, okay, our data has to reside only in our region, then you can create a service in that region and put your data there instead of going to that region and creating a data center. And it helps latency requirements also. So if the services are running within the same region, it will be faster to access than running all across the other side of the globe, right? And in case if you are not able to do that, in case if you are not able to set up a service closer to your region, for latency alone, we have other solutions such as CDN, that stands for Content Delivery Networks, and can be considered as a cache. We learned about cache few slides before, right? So this is kind of a cache where data is stored near to the user. So for example, you are watching a video that is hosted in United States from India. So first time somebody watches, that will be a cache near to your location within your region within India. And then next time when you are accessing it, it will be accessed from within that cache or region nearby. So that is CDN. But if there is a compliance regulation, then definitely you will have to set up within that region itself. Hope it is clear. And for security also, you can always find a cloud solution that matches your security needs. For example, if you want maximum control of security, infrastructure as a service lets you manage the operating systems and install software, including patches and maintenance. If you are a security freak and then you know everything, then you can go with maybe infrastructure service. Or if you want patches and maintenance taken care automatically, and you can focus on the actual development and deployment and other things, then you can go with the platform as a service. Depends on what you need. And most of the cloud providers will provide both of these options so that you can choose. And cloud providers are typically well suited to handle things such as distributed denial of service attacks. The cloud providers generally provide recommendations or templates or blueprints for governance and compliance and help ensure that all deployed resources meet regulatory compliance. So in most of the cloud providers, they may provide recommendations and blueprints that you can follow and implement also. Okay, so you get a lot of advantage moving to cloud rather than doing everything on premises by your own. From a security perspective, predictive cost perspective, most of the cloud providers have tools for predicting how much cost I will incur if I continue to use this service. So, for example, if you consider Azure, Azure has a pricing calculator, and in Azure pricing calculator, we can see, okay, based on this configuration, this usage for this savings plan, how much I will be charged at the end of month. So you can calculate all of those things using these calculators. And in Azure and AWS tracks, we will be seeing examples of these calculators. Agility. Agility is the ability to move quickly and easily. Cloud allows us to move quickly and easily than on premises with respect to many features such as high availability, scalability, elasticity, fault tolerance, disaster recovery, global reach, latency security, predictive cost, etc. It doesn't mean that all of these features are available only on cloud, but setting up these things efficiently on premises require a lot of additional efforts and cost that we can easily invest in our application development. And with respect to agility, how many of you have heard about Agile? So Agile embraces changes, right? And in your cloud deployment model or in your application deployment model, you have deployed to a server of instance type X. And then later you feel like, okay, I need to use a server of instance type Y. We have learned about a CPU, GPU, etc., right? So those kinds of changes you can definitely do on premises also, but how easy it is. Okay, how easy it is to make such changes on premise. You already bought a system, and to change it with a different configuration, you will definitely incur losses. But with the cloud, you will have to stop that server and then migrate it to whatever server type you want, and everything is back as before with a better streamlined performance. So it is very easy. So from that moment, you are not charged for your old instance or old configuration. You are only charged for your new configuration. So cloud provides a better agility compared to on-premises. So summary of cloud benefits. Even though I have mentioned the cloud benefits, these are not just benefits of only cloud or features of only cloud, but it has advantage on cloud because you can achieve these with less effort and less cost. Okay, most of these things: high availability, scalability, elasticity, fault tolerance, disaster recovery, agility, predictive cost, security and compliance, low latency, and even global reach. Earlier, if you wanted to do something for a continent from another continent, it was very difficult. As a startup owner, as a individual, only enterprises and bigger companies used to have that kind of reach. But with cloud, anybody can reach globally and deliver. Quickly, we will go through some questions to check our understanding. So some of these questions are from part one, but still, let us see who remembers about which expenditure model is used with pay-as-you-go subscription models. Okay, we learned about the scalability in this session, so you may have forgotten everything from first session. So that is why I mentioned. So this is from first session, not second session. So expenditure models, there are two expenditure models mentioned here. It is operational and capital. And the answer here is operational. Okay. So do not forget everything when you go to the next session. Always keep everything or max of the things in your brain. A company can extend private cloud by adding its own physical servers to the public cloud. True or false? Quickly. This is also from part one of this series. None of you are revising or keeping things in mind. You cannot do anything physical on public cloud. Okay. You are not managing anything. You don't have any flexibility to add any physical things on public cloud. Only your cloud provider can do. Clear? A company plans to migrate their on-premises servers to cloud. Which of the following administrative responsibilities would be reduced by this move? Quickly try to answer. There are two answers. A and C, ensuring a failed server hardware is replaced. Managing physical security. Anything physical, anything hardware, it is all abstracted away in cloud. Which of these cloud deployment models provide a choice to use on-premises or cloud-based services? It's very easy, right? Hybrid. So this is from part two, today's session. Replacing servers with more capacity ones or increasing its capacity can be called as, give two options. Replacing servers with more capacity ones. So we learned like this, right? Replacing, adding more. Replacing with the more capacity ones, it is vertical scaling. Vertical scaling means what? Going up or down, right? So one option is definitely F. What is the other option? Going up means scaling up. So what is the answer? It is BF. Okay, clear? So adding more servers and processing in parallel can be called as. So this is adding more servers and processing in parallel. It is called as horizontal scaling. So one is E. And adding. Adding means scale out, right? So it is A and E. And final question. I need all of you to answer this based on your understanding. Which of these can be part of auto scaling in cloud? We learned, right? Auto scaling is generally applicable for one of horizontal or vertical scaling. Which of these are part of auto scaling in cloud? Give three options. So it is scaling out, scaling in, and that is horizontal scaling. Clear? So if you have any doubts or any questions, anything you can ask now. Otherwise, we will wind up for today. So tell me one thing before we wind up. Have you learned anything new today? Okay, second question. How many of you feel like I have to go back and revise part one recording once again? So if you have any doubt, you just ask. Okay. So we have classes at evening India time and then morning India time. So if you miss evening, you can attend morning one. So morning one is on the next day. So if you miss evening, you can attend morning one on the next day. And if you think like, okay, tomorrow morning I cannot attend, then you can attend the evening one today. And if you miss both, you can watch a recording and then ask doubts on the weekend session. So you have multiple options to learn together with me. The only thing you have to do is just learn, ask doubts, and do all the labs hands on. And that is the best way to become a master in cloud. Okay, so there is no shortcut to success, and there is no shortcut to cloud mastery without hands on exercises. So recording for first class was already shared. Okay, you can go to CloudRig's YouTube channel. So as you can see here, I have not been much active on this channel for last few years. There is a lot of gap. You can see the old me during Corona times in a small room. Okay, so and then you can find the latest ones. This is the one like a cloud computing fundamentals part one. Then there is this shortcut you can always remember if you want to go to this YouTube channel without typing everything. Just CYT for CloudRig's YouTube channel .train.so. Once you click, it will automatically redirect. Okay. Alexa, please say intro. Okay, so that is my Alexa saying the intro. So just save this link so that it will be easy to go to the channel. Remember, this is a cyt.train.so. So the recording is there for first session, and the recording for this one I will upload soon. So if you are new to cloud, these two are mandatory, irrespective of whether it is Azure cloud or AWS cloud or GCP cloud or any other cloud. And please take your learning seriously. And from Monday, we'll be starting with the Azure administrator. Okay, and we will do it hands-on, fully hands-on this time. So please do it. And we have a dedicated team. It is not just me, right? There is a team that is waiting to help you on any day of the week. All you have to say is, I have a issue in your C1 or Keva group, and the team will help you out. Okay, team will come join online over Zoom meetings. As you know, the Keva or C1 group has 24/7 Zoom meetings, which means it is always running. You just have to click. You don't have to schedule anything, and the team will help you. The team will say, okay, today at this time we can meet. You can agree upon a time, and then you can meet, and then they will help you fix the issue. So that's it. You have everything here for learning, but you can only become a cloud master if you put that effort. So a team on standby or me taking sessions or me uploading recordings, none of these things will make you a cloud expert. You have to learn, you have to try things, and you have to ask doubts and attend quizzes and learn. So any questions, doubts about today's session or about CloudRig's membership program or about Azure Administrator course or about the AWS sessions that are going to start from coming week, or even how to participate in my book, anything you can ask me now, or you can connect with me. I am also part of a Keva group. So in the Keva group, you can get my direct contact also. You can directly WhatsApp me or talk to me. Okay, there is a question. Have question. We can unmute and ask if you want.
Hi, Hatem. My name is Junaid. Actually, I was just going through the link which one of your teammate has given. I have
Okay.
some doubt on the program. Does it also give an access to the servers? And do we have any kind of a live project we can try to work on? Because we are new to the cloud. Of course, we're going to practice. And do we also get further any kind of project we can try to work on
Okay.
as part of the membership?
The Azure Administrator course. I hope you may have seen the project plan in the groups. Otherwise, we are planning to set up a WordPress based website on Azure cloud in different approaches. So we have just learned a few things, right? Infrastructure as a service, platform as a service, etc. So we will explore many of these things through hands-on project exercises that are not really covered in Microsoft syllabus. For example, we will deploy this on a virtual machine, which is infrastructure service. And the second one, you can do it on platform as a service using Azure App Services or Azure. We learned today, right? Platform as a service on Azure App Services, or we can use something called as Azure Marketplace. And next, so next we will also see how to do the same using container as a service. And within container as a service, we will see container instances, we will see Kubernetes. So it is not just the syllabus that we follow, right? We have live projects. Make sure you just not learn, but you will understand and you are 100% hands-on. Labs also, we have created almost 161 labs, which is much higher than what Microsoft by default provides. And that is also listed in the brochure. So any questions, you can always contact the team over email at help@cloudrix.com, or you can ask in our Facebook chat or Facebook group. And if you are part of C1 or Keva group, then you get all support from lot of admins, not just a few admins.
Yeah,
Everybody.
I'm part of the F group. I was about to enroll myself in a membership, so I thought just to understand what's the benefit, and also will I be read by someone else from the team to guide me for the next step and so on. But I'm just now reading through the other information which you have provided, and I'll try to enroll the membership and see wait for your team for the next step on this.
Okay, so once you enroll the membership, you get free KV access also if you are enrolling for the ultimate membership. So you can, so once you enroll, you can send a screenshot to the WhatsApp number. It is +91 for India. And if you are from India, you don't have to mention +91 and 90944 03333. So I'll send it in chat also.
Chat, yes. Yeah. Yes, please.
And then they will add you to the WhatsApp group also. So the WhatsApp group is the most beautiful thing that we have, and that is what separates us from all other training providers or training institutes. And then many of the others will also have a WhatsApp group, but having multiple 24/7 running Zoom meetings, you will not find in much places. And I am always available for any question or escalation or anything. As you know, like I may not be able to talk individually to everybody every day, but I will try to come over Zoom and then talk like this. But if I have a policy, we have a policy, if anybody ever gets part of a layoff, or they are in need for a job change, or they have an interview coming, then I try to talk to them personally. So some limits, so that otherwise I am human, right? I cannot be in multiple places talking to multiple people at the same time. But if you are in real need, I'm always there to help in person. So that is it. Anybody else? Any questions, doubts, anything?
No, thank you for me.
Yeah, for you it is clear, right?
Yeah, I'm clear. I'll take it further from you. Thank you so much.
So that membership link also, can somebody share it here in case?
Yeah, I have it. I see on the chat. I'll just take it.
Okay, it is just cloudrix.com/membership. So that's it. Anybody? Any doubt? Any question?
Nothing for now.
Okay. So if nothing, let us wind up for today. And I hope you will watch the previous recording, this recording, and be prepared always. Okay. So bye-bye for now, and see you all in the next class.
Thank you.